got back from a business trip last week from Washington, D.C., and the weather was fairly clear on the west side of the country, as you'll see shortly. This is satellite imagery over the western United States, and notice the clouds over Colorado and Utah. And I've superimposed the flight path over this image. Our sighting of the mountains begins with the Culebra Peak mountain range, as shown here in Google Earth. It is straddling Colorado and New Mexico, as you can see in the box. I only noticed it around Amarillo, but as you'll see in the images, it is very noticeable. Probably could be seen at twice the distance easily. Unfortunately, you know, when I'm flying far away, the weather is bad, but when I'm close, the weather is nice. So still waiting for that perfect weather so I can fly to Houston and be able to see these mountain ranges clearly. But anyway, let's begin. So I'm gonna step through my images. I'm around Amarillo. Now that's the UTE reservoir. And way in the distance, initially I thought those were clouds. I mean, they look like clouds. But as you'll see, when we adjust the contrast, we begin to notice that these are actually mountains. So really incredible. Now we have the advantage of motion here. We spot something from far away and then we get closer and closer, and the confidence goes up. You'll see this mountain from different angles as I'm getting closer to it. But look at that. This is incredible, and it stands way tall. That's over 250 miles, 200 to 270 miles. And over to the right of it, we noticed Blanca Peak. So anyway, there's the reservoir. Let's keep going. Now, let's see. Okay, let's pick this image and adjust it. So I'm adjusting here the levels, as you can see. And we can tease out a lot of the detail that's in the image. Due to haze, you know, the image becomes, wow, look at that. Yeah, due to haze, the contrast is ruined, but we can bring back the contrast. Now look at those two dots to the right. I think if those are not clouds, they're kind of low. Those could be Blanca Peak, way out there, maybe 300 miles. Now, what I'm doing here is I'm adjusting, but then I'm canceling and reverting the image back. I will process these images later. I just did a screen grab here real quick because I didn't have time to put together you know, a more detailed presentation. But anyway, now we're moving closer, and we'll keep looking to the north, obviously, because I'm on the right side of the airplane. And yeah, look at these wide views. Wow, just incredible. Later we'll talk about the slight curvature we see, so don't get too excited just yet. But yeah, it's incredible. This lens is the same like the one I used last time. Pretty good lens. And the weather was clear. I'll show you some visible images later and compare them to infrared. But not as clear as last November when I took those incredible photos of, you know, the Sierra Nevada and the Colorado Rockies. So here we're seeing part of the Rocky Mountain chain in northern New Mexico and beyond. As you can see, the ones in the front are kind of towards the northern side of the state, and then beyond you see the Colorado Rockies. Look at that. This is insane. It's like, 200 to maybe 400 and more miles. Look in the distance. Wow. Now you can see the weather that we saw in the satellite imagery, right? It's way out there, and we can see it above the mountains. Isn't that incredible? Now here we're still progressing. We're not quite. Yeah, look at that. We can see another body of water, and we can see the reservoir to the right of the image. Look at this wide open region. Wow. Here you go. Let's pick this image. Look at those mountains now. They're more clear. We've closed the distance somewhat, and probably 200 miles here. Look at that. So clear. Unbelievable. Now let me scroll and find a good image here. Here, I'm just trying to bring out those mountains underneath the clouds. Now we're operating, these are infrared images at 830 nanometer. We're imaging scattered infrared light, not thermal, so the sun is illuminating everything. So clouds actually cast a shadow on the ground, so it's kind of hard to see the mountains, but if we adjust contrast and the levels, we can see underneath, Notice how the geometry is changing here. See, we can do triangulation and figure out what we're seeing, and how far. I've used that in my first aerial infrared video, the Epic 500 mile. So yeah, look at these mountains, and we can see another mountain range behind it. And then there is the haze. Way to the left, see, we can tell the mountain peaks are slightly below the haze and the clouds are above. Let's find another one. Okay, let's try this one. And notice now we can sort of tell there is a pronounced curve. Well, we'll deal with that later, but there's areas that seem incredibly flat, and then there's areas that seem to have quite a bit of curvature. And the atmospherics and the cloud cover have a lot to do with it. Here we go. Now I'm looking at the Culebra Peak, a little bit to the right side of center, over the mountain peaks in New Mexico. Isn't that crazy? We're actually kind of north of White Sands here. And looking across New Mexico into Colorado. Incredible, folks. I'm just loving this aerial photography. Just incredible. Here you go. Look at that cloud cover. Yeah. There's a beauty in this wide angle images, but it's also advantageous to zoom in. I love the clarity of this Sony Alpha 6000, but I kind of miss the incredible zoom that my other camcorder had. I may start taking that one up again. Here we are. I'm trying to see what's underneath this cloud. Look at those mountains. This is crazy. Look at that. See, we have to adjust the whoa. See, we gotta work the levels to tease out this detail. It's in there, but you know, due to haze, we're limited. That was incredible. Look at these wide open areas. Wow. Look at these curving land features. Looks like a stair step. Man. Look at all that cloud cover with the mountains underneath. See that? Colorado Rockies, man. Sheesh. Yeah, in my previous video, it wasn't as clear. I mean, I could tell, I see it clearly on my computer, but some of you were doubting. You thought I was pointing at clouds or something. You know? But yeah, I mean, unless you see it clearly, you have doubts. You know, folks, I've been flying a lot. I look out, I kind of know the direction from which the mountains appear. And so I have a pretty good sense of what I'm looking at and how far things are. I've been doing this for, you know, close to 2 years. It's such a unique vantage point to be up in the sky. Yeah, look at that. Look at these mountains. Colorado mountains that just pop out when we adjust the levels. Yeah, I'm loving it. See, now the round, you know, the lighting, that's vignetting. You know, I didn't bother to adjust vignetting in Photoshop. It doesn't seem to work very well, but that's due to the lens. It's unfortunate, but yeah, there's vignetting. Now with my telescope, vignetting is almost eliminated when I use the APS-C sensors, because the barrel of my telescope is 2.5 inches, so very little vignetting. But with these camera lenses, unfortunately, when I adjust the levels too much, we start to see vignetting. Yeah, look at that. See, it's lighter in the center. Oh, look at that. Man, those are Colorado Rockies down below the cloud cover. Look at that. This is just incredible. Now those were the peaks that I saw in my first aerial infrared video, the Epic 500-mile visibility. Yeah, it was in the springtime, and there was a lot of snow on top of the mountains. So the time of year is also advantageous. I'm starting to think the best is really maybe in the fall. Now okay, so now we're approaching Arizona, and that's Humphreys Peak around Flagstaff. Look how clear we can see it. Oh my goodness. And way to the right we see some peaks farther out. And unfortunately there is some haze and cloud cover, so we cannot see it against the Colorado Rockies, but hopefully later in the fall on one of these trips I'll be able to duplicate that epic 500-mile visibility with this better camera. But yeah, that's Humphreys Peak, and soon you'll see the Sierra Nevadas. Now I'm approaching, there is, oh yeah, that's the Colorado, that's Havasu. Way in the distance we see a white line. Those are mountains in Utah. Just crazy, man. That's probably like 400 miles away or more, Just insane. Unfortunately, I didn't notice those mountains when I was taking pictures, so I didn't zoom in on them, but man, it's crazy. That's why it's important to have a good viewfinder, camera with a good viewfinder. That's why I like the Sony. Now, here we go. That's the Sierra Nevada mountains. Just incredible. I'm seeing them at, I don't know, over 200 miles or so. Look at that. They may say, without zooming in, you can easily assume these are clouds. When you start zooming in and adjusting levels, you realize that that's the snow level on top of the Sierra Nevadas. And that's the disadvantage, folks, when I'm flying and I'm looking, if I don't have a good viewfinder, I cannot tell what I'm seeing in there. And so I may not zoom in on something, So I have to see it clearly in the viewfinder so I can zoom in on it. Notice it and zoom in. But yeah, look at this stuff, man. This is just crazy. We're looking now. The angle that we're seeing these mountains at doesn't quite jive with the map. And I've noticed that in a lot of my analysis, I'm seeing the mountains at a different angle. And I'm preparing a presentation on the horizontal perspective changes. This is all because, we did not take in consideration atmospheric refraction and the proximity of the sun. And so what is a constant latitude designation, it's actually circular. So we're seeing, this circularity to land features in the distance. I'll have a slide on that later. It's just incredible. And this only starts to become apparent, at over 100, 200 mile visibility. Things are just beginning to shift. They're not quite like the globe says. On my cruise through the Panama Canal earlier this spring, I noticed, interesting solar angles, and yeah, I'm still working on that. I'm just so busy flying this month, and the next is gonna be crazy. But there you go. There's the Sierra Nevadas, folks. Look at that. Just incredible. Just incredible stuff, folks. Now let's see here. A few more photos. I've zoomed in here. Oh, look how clear. You can see them here. Yeah, it helps to, fly away from the mountains, notice them initially, and then as you get farther and farther away, you can track and know what you're seeing. But when you're approaching mountains, sometimes you may not notice them until you're too close. So yeah, that's why I kind of try to take pictures of the horizon, even though I don't notice a particular feature, because later, on the computer I can analyze all this stuff. And then once I spot something, I start backing away in the imagery to see how far away I saw it. So yeah, I'm trying to perfect my techniques here to see this flat earth from above, Yeah, look at that. Snow-capped Sierra Nevada mountains. Way in the distance. Yeah, just incredible, folks. Look at that. That's Big Bear Lake. Yeah, that darkness is water, as you've guessed by now. And we're looking way out there. Let's do a horizon elevation analysis. So I use my theodolite app in level flight, and that's important. The airplane cannot be banking, and measured where I thought the horizon should be. But as you'll see, it's not there. So now I'm looking and comparing it to the wing, and based on that and the infrared imagery, when I line them up, I'll be able to tell what the elevation angle is to the infrared horizon that I'm seeing. Now here obviously there's a lot of haze, and I've seen people trying to calculate the radius of the earth by pointing down at the haze. As you'll see, it's very inaccurate to do that. You have to see the ground clearly. Now, in the upper left, we see the latitude and longitude and altitude. The GPS did not update in flight, and those are actually the coordinates from Dulles International Airport, where I took these next images, trying to understand if my theodolite is calibrated. So here I'm at Dulles, and I'm looking across at an airplane that seems similar to mine, 737, and I'm pointing at the windows. Slightly below here, it looks like it's -6 degrees, and then I'm gonna try to bring the theodolite to 0 degrees and see where that points. And here we go. That's a 0 now, and it's slightly above the windows. Now, I notice with the theodolite, it's accurate if I hold it really absolutely still, but when I press the button on the screen to take a picture, sometimes I jolt it and move it. So I think it incurs a little bit of an error. But anyway, if it's off by no more than like -0.3. It's biased down a little bit. Now let's have a look at this awesome analysis image. So here I took an infrared picture, and also took out my cell phone and snapped a picture in the visible spectrum, obviously, and I lined up the ground features. And as you can see, if I draw a line out to the wing, it kind of falls in between the 0 and the -2.8, and I really determine where it touches the wing by those 3 notches. Do you see 3 notches on the leading edge of the wing? One a 0, and then one a -1.6 degrees. Yeah, so based on that, I can create that scale and sort of determine that the horizon is somewhere around negative, 1.6, maybe 1.3 if I'm off a little bit. Anyway, it's in the -1 degree dip angle. Now, why is that? Why shouldn't it be, at 0 if it's flat Earth? Now look at the globe horizon. It should be at about -3.4, but it's not. So it's not a globe, clearly, but you could say, hey, it's not flat either because the horizon appears to be at -1.6. Well, there's a reason why that horizon, the apparent horizon, is down. It's because of haze and refraction. The shallower the angle, the more it penetrates to the atmosphere, which has water and of course absorbs. But there's also scattering of sunlight. So, one phenomena kind of fights the other. So we see some haze, we see some bands of, light, and, the rest of the flat world is actually contained in that, angle there. Yeah, I mean, the distances get crazy, The shallower the angle, the farther you see. So, I don't expect to see, thousands of miles through the atmosphere and haze. It's not possible. So, here's my point. Because the horizon is seen at a lower angle, even though it's not the globe angle, we should see a curved horizon. That's just geometry. If we're looking down, it's as if we're seeing a disk underneath us. And so depending on how wide our field of view is, we should perceive curvature. So seeing curvature doesn't mean the Earth is a globe necessarily. It's how much curvature you see and why do you see it. I hear people say, oh, pilots see curvature from 80,000 feet. See, the Earth is a globe. No, all you can say is, I see curvature. You have to analyze, why am I seeing curvature? In this graphic here, notice that we intercept the visibility boundary with a certain field of view. So we see an arc, a portion of the edge of this disc-shaped visibility boundary, and really it's the atmosphere that limits the minimum angle that we can look at, the theta. So if you look at the yellow line, right, the farther we look out, the shallower the angle. And at one point, we reach a critical angle and, things refract upwards because, the atmosphere is layered and, there's atmospheric attenuation, there's water molecules in the atmosphere. There's a lot of phenomena, There's a little bit of downward refraction, but then there's upwards between different, layers of the atmosphere. It's kind of complex. Down to the ground, there tends to be more upward refraction. The temperatures are, higher, there's gradients. So anyway, at those shallow angles, we're limited. So that kind of defines a, disc-shaped visibility area, which resembles a disc. So when we look out towards the horizon, or the perceived horizon, if we have a wide field of view like our eyeballs, which have a short focal length, therefore a wide field of view, we're going to perceive quite a bit of curvature. The other thing is, the figure of 80,000 is quoted, you know, because once you get up there, the atmosphere, the layers of atmosphere, um, compared to our altitude, are pretty small. So when we look out, that haze, you know, becomes well defined and very close to the ground. So I think at that point you begin to see, um, better, almost as if you're looking through infrared. You see a well-defined edge. So if you look in the visible, you gotta be higher up to see that well-defined edge. But in infrared, we can perceive that at lower altitudes. I tried to make that point in one of my comments on the previous video. So anyway, this is the geometry, folks. That's what's really happening here. A little bit of refraction, attenuation, limiting our view in the distance. And so we're stuck with this, depression angle, but it's kind of constant. That's what's strange. Even from 200 feet up looking over the ocean, you're kind of stuck at like negative, 2 degrees, 1.5 degrees. So very strange. Now, obviously, there could be other phenomena. For example, we're looking through a curved glass window, and so that may introduce a little bit of distortion. Then we're obviously dealing with lenses, and those kind of have a little bit of distortion. But by and large, it's really the atmosphere, because the upper levels of the atmosphere appear as a straight line. See, that's the blue line I drew there. But it's only underneath where it kind of appears curved. We saw that in my images from Louisiana. The ground extremely flat, and then we see that curved field of view, the limit of visibility. But yet, when we look above, the atmospheric banding above is fairly linear and straight. So that's what makes me think that the windows really might not be contributing that much to this phenomena. It may be imperceptible. Now, mountains that have snow on top can be spotted at great distances, because not only is contrast improved due to the snow, but also they sit higher up above the atmospheric distortion. And best time is in the winter time to spot mountain ranges way in the distance. So I hope later in the year to have another opportunity to see the Colorado mountains clearly. Fascinating stuff, folks. I hope you've enjoyed this presentation. God bless, and do stay tuned for more. Don't forget to subscribe.